Good morning, students. Today I am taking the next topic, that is path matrix. That means, suppose you have been given a graph, we need to find out is there any path from any one node V1 to any another node Vk. If there is a path, then in that matrix we will be making a matrix, that means two-dimensional array. Then that particular entry would be set to 1. Like if there is a path from V1 to Vk, then that entry would be 1. Otherwise that entry would be 0. Okay, so I'm taking an example. Suppose you have been given this graph. There is one graph having 4 nodes, x, y, z and w, and this is the adjacency matrix of that. Okay, so I'll repeat this thing. What is that adjacency matrix? If there is any edge from one node to any another node, then that particular entry would be 1. Otherwise that entry would be 0. Like in this case, if you will take x, from x there is only one edge from x to w. Okay, so only that entry is your 1. Otherwise x to y no edge, x to z no edge, okay, x to x no edge, so all those entries would be set to 0. Okay, so this is called your adjacency matrix representation of this graph. Now consider, now there are two methods to find out this path matrix. First I'm taking this method, then other one is important, that is by using Warshall's algorithm. Okay, now this is a, you consider this is a raised to power 1. A raised to power 1 means here you take this one like akij, that is the ijth entry in the matrix A raised to power k. That means there are, how many paths are there of length 1? Okay, A raised to power 1 will give you, suppose this thing, it is saying there is one path of length 1. Okay, so you need to find out the paths of length 1 first, then you need to find out the paths of length 2, paths of length 3 and paths of length 4. So A raised to power k gives the number of paths of length k. Of length k is very important. Like suppose if you are going from y to w, there is a path of single length, like directly you can go from y to w. Okay, now there is a path of length 2 also. Okay, which is that path? You can go from y to z and z to w. Okay, so y to w, if you will take this y to w, this is 2. So what's the meaning of this 2? 2 is that there are two paths. Okay, what is the next path? You can go y to x and x to w. So there are two paths. And what is the length of that? That is 2. One is this, other one is this one. Okay, so it is saying there are two paths of length 2. Okay, so again I'm taking this thing. What you have to do, first of all we will make one adjacency matrix A. Then you need to find out A raised to power 2. What it is saying? It is saying that how many paths are there of length 2. Then it is saying A raised to power 3. That means you need to find out how many paths are there of length 3, and then how many paths are there of length 4. If there are 4 vertices, you need to find out till A raised to power 4 only. Okay, you can't have any path of length 5 or 6. So after that, suppose this is A raised to power 2. How to find out A raised to power 2? You take one more adjacency matrix A and multiply that A with this A. That is a matrix multiplication. Okay, you will get A raised to power 2. Then A raised to power 3, you will multiply these two matrices, you will get A cube. Then is A raised to power 4. So you need to take one more A raised to power 2 and multiply these two matrices, you will be getting A raised to power 4. Okay, so all these matrices are giving you how many paths are there of length 1, 2, 3 and 4. Next you take the summation of these. Okay, when you are taking the sum of these, then any ijth entry of this matrix gives the number of paths of length r. R is here, in our example this R is 4. It will give you the number of paths of length 4 or less, because this is the path of length 1, path of length 2, 3 and 4. So when you will take the summation of this, it will give you the number of paths of length 4 or less. Okay, from any node Vi to Vj. So if I will take the summation of this, you are getting this one. This is your B4. So what it is saying that there are two paths of length, either 1, 2, 3 or 4, means 4 or less. Then it is saying there are three paths from X to W of length 4 or less. And just see this one, Y to W, it is saying there are 8 paths of length 4 or less. Okay. So this is your B4. Now how to find out the path matrix? In order to find out the path matrix, what we will do, if there is any zero entry, you will write down like this. But if there is any non-zero entry, you will put the 1. Okay. So here what's the meaning of 3? It was saying there are three paths. That means there is a path from X to W. That means that would be set to 1. It is saying W to X entry that there are two paths from W to X. So that entry is 1. So Pij, that means this is your path matrix. In this, each entry from any node I to J would be set to 1 if there is a path from Vi to Vj. Otherwise, it would be 0. So this is called your path matrix. Okay. So this is the one way to find out the path matrix, and this is also called the transitive closure of a graph. So if you have been asked that write down the transitive closure, that means you need to find out the path matrix. Okay. So how to find out the path matrix now? Suppose when any graph is given to you, what you have to do, that first of all find out the adjacency matrix A. Next, if there are 4 nodes, find out e raised to power 2, e raised to power 3, e raised to power 4. But if there are 5 nodes, you need to find out e raised to power 5 also. And then take the summation of all these. Then this algorithm, this matrix will give you the number of paths of length 4 or less. So what you have to do, you need to make one more matrix, and in that matrix you will take any non-zero entry in B4 is replaced by 1 and any zero entry will remain same. So this is defining your path matrix. Okay. So this was the one way. Then there is another way, that is called Warshall's algorithm, to find out the path matrix. Okay. Now, with the help of this Warshall's algorithm also, you can find out the path matrix. For that, I need to make one formula. What is that? Here I have written Pkij. Okay. Now Pkij will denote any entry in the matrix Pij from I to J. If there is a simple path from Vi to Vj which doesn't use any other nodes except possibly V1 to Vk. Okay. That means if I'm taking any matrix Pkij, what's the meaning of 1? It is saying if there is any path from I to J which doesn't use any another node except V1, you have to start from, suppose I'm naming all the nodes like V1, V2, V3, but you have to go till Vk only. There may be some nodes Vk plus 1, Vk plus 2, but you don't have to take that. You need to consider the nodes only till Vk. So by using Vk, first Vk nodes, if there is any path from Vi to Vj, then that entry would be 1, otherwise it would be 0. That means here also I need to find out many matrices. First matrix is P naught Ij. So P naught Ij, what's the meaning of that? Any entry in that would be 1 if there is a path from Vi to Vj which doesn't use any node except, what is that? V naught. So I won't be taking V naught node. So what's the meaning of P naught? P naught means if there is a direct edge from Vi to Vj, then that entry would be 1. Okay. So this would be your like adjacency matrix actually. A and P naught would be same. Now what's the meaning of P1? P1 is saying that if there is a path from Vi to Vj which doesn't use any another node except V1. That means you just need to consider V1. You will go through V1 and you will say, is there any path from Vi to Vj? If there is any path through V1, that entry would be 1. Now what's the meaning of P2? P2 means if there is any path from Vi to Vj which doesn't use any another nodes except what? You start from V1 and V2. So you need to consider only two nodes, V1 and V2. By using these two nodes, if there is any path from Vi to Vj, that entry would be 1, otherwise it would be 0. So you need to remember this thing. What's the meaning of Pkij? Okay. So first of all, I'm taking one matrix, adjacency matrix, and what would be P naught? P naught is if there is a direct edge from Vi to Vj, that entry is 1. That means P naught is same like the adjacency matrix A. Okay. Now we need to find out Pkij. Pkij would be 1 if one of the following two condition is true. Now what's the meaning of this? It is saying that you take, instead of k, I'm taking one example, you say 3. That means I want to check, is there any path from Vi to Vj which is using how many nodes? V1, V2 and V3. Now it would be 1 if P2ij is 1. That means if there is a path from I to j which doesn't use any another node except what? V1 and V2. So if previously you have calculated P2ij as 1, then obviously it would be 1. But suppose it was 0. Okay, then what I will do? I will go through from I to, first I will go to 3. Okay, I have to go from I to j. Okay, if there is no path from I to j which is using the nodes V1 and V2, what I will do? I will go from I to 3 and then from 3 to j. Okay, I'm using the new node, this one, third node also, because by using first two nodes it was 0. So I'm using this one. So Pki minus 1 Ik is 1 and Pk minus 1 Kj is 1. That means if I to 3 there is a path, if this is 1 and 3 to j is also 1, then I can say there would be a path from I to j also. Okay, so one of these two conditions should be true. So this is very important. What is that? That Pkij is 1 if Pk minus 1 Ij is 1, or would come Pk minus 1 Ik is 1 and Pk minus 1 Kj is 1. Okay, so I would be taking one example, then it would be clear. I'll come to this algorithm after taking that example. Okay, now take this graph. This is x, y, z and w. This is your v1 now. Okay, because I'm using the word v1, this is suppose v2, v3 and v4. First of all, this is your adjacency matrix. Okay, so what I had told you, that this adjacency matrix is what? This is your P naught. So P naught is this adjacency matrix. Okay, P naught means it is saying if there is a direct edge, like it is saying there is a direct edge from x to y. That's why this entry is 1. There is a direct edge from x to w. That's why this is your 1. Fine. Now I need to find out what? I need to find out P1. That means I need to find out the paths when those paths are passing through V1. Then when they are passing through V1 and V2, then V1, V2 and V3. And this is when the paths are passing through what? It may be V1, V2, V3 or V4. That means if there are 4 nodes, you need to find out till P4. Okay, firstly P1. P1 is what now? You need to put the value of k. What is k over here? 1. So put the value of 1 over here. To find out any entry, suppose this is your 1, this is your 2, 3 and this is your 4. Similarly, this is 1, 2, 3, 4. So any entry you can find out just by putting the value of k as 1. Okay, now here I need to find out P1. What's the meaning of P1? I need to find out, is there any path from any node, suppose V2 to V3, that is passing through X. Okay, so suppose this is 1. Okay, if any entry is already 1, you don't need to find out that, because that is saying there is a path, like it is saying there is a direct edge from X to Y. So I need to I don't need to find out that entry. I don't need to find out this entry X to Z. I don't need to find out the entry X from X to W. Okay, so that would be written as such. I'm interested in all these entries that are 0. Now you take this one, y to x. Now what's the meaning of y to x? That means it is saying I want to go from y to x. There was no direct edge. Now I'm saying, is there any path that is passing through x, through v1 x? Okay, so actually you are going from y to x only, there is no path. Okay, so it is 0. This is y to y. If you want, there is no loop, so don't consider that if you want. Okay, but y to y through x, is there any path? No, I can't go from y to x only, so there is no path. Okay, then is y to z. I want to go, okay, this is now it would be clear. I want to go from y to z through x now, through v1. Okay, is there any path to go from y to z through x? No, because I can't go from y to x, although I can go from x to z, but there is no path from y to x. Okay, so I can't go. So again, this is 0. So actually in this example, P1 is similar to P0. Now come to this one. This is also similar to this one. What is P2? P2 is saying that can I go, suppose you take one entry y to z, that is passing through which node? V1 and V2. That means x and y. I want to go from y to z by passing through either this and this. No, because there was no edge. So this is also similar to this one. Okay, this is important. I will take this one, P3. Now in P3, again I am telling you that I am interested only in these entries that are 0. You take this one because this is becoming, this was already 1. You take this entry. I am taking this one. I want to go from W to Y. I want to go from W to Y by using which node? I can use V1, I can use V2, I can use V3. Okay, and I want to go from W to Y. Is it clear? Okay, now just see, before this entry was your 0, W to Y, this entry was 0. It was saying that it is not possible to go from W to Y by using V1 or V2 because W to X, no entry is there. Okay, so I couldn't go there. Now I'm saying that can I go from W to Y by using V1, V2 and V3? Okay, because this is your P3. Now how to find out that entry? Okay, um, write down here P3. You want to go from W to Y. If you want, you can write down here 4, here 2. Okay, so what is that? It will be 1 if P2WY is 1, P2, because K minus 1, K is 3, here it would be 2, P2WY, or it would be P2. You can go from W to Z because what is K? K is your V3. And what is V3? V3 is your Z. So you can go from W to Z and Z to Y. Okay. Now what is PWY here? You need to look for this matrix W to Y. That was your 0 entry. Now find out P to W to Z. W to Z, this is your 1. So this is your 1 entry, and Z to Y, this is your 1 entry, 1. And what is W to Y? It was your 0. So it is saying 0 or 1 and 1. That means by using V1 and V2, I can't go from W to Y, but I can go from W to Z. That means by using V3 node, I can go from W to Z and then Z to Y. Both were 1, so it would be your 1. So this entry is coming as to be 1. Okay, so this is the meaning of P3. Now find out this entry. This is your W to W. That means you want to go to W, you want to start from this and come back to this one. So can you go there? So we will check that. By using V1 and V2, there is no entry because I can't go to this and this. I can't go here and then this and this. But I can go W to Z and then from Z to W, I can come back. So this entry is your 1. Okay, because by using V3, I can go that. So it would be 1. So if you want, don't use this formula. If your graph is very simple, directly you can find out. Okay. So then you will find out P4. Okay, when you will find out P4, P4 is when you are passing through, you are using W4 also. you take one entry that was already 0, you take okay, this one only, Z to Z. You you want to start from Z and come back to this one. Okay, by using what? By using now either V1, V2, V3 and V4, any node you can use. Okay, so yes, from Z to W you can go, and then from W to Z you can come back. Okay, so that's why this entry is your 1. You take one more entry like Y to Z, Y to Z, Y to Z you want to go. Okay, now you can go from Y to V4, just see W, I'll make it Y to W and then W to Z. Okay, so that's why this entry is 1. So when you will find out, you will be getting your path matrix like this. Okay, so this is your path matrix. In this path matrix, I can't go, it is saying you can't go from X to X, Y to X, Z to X, W to X, because there is no edge actually from Y to this X, and there is no path. Like you can go from Y to W, but again from W to X you can't go. Okay, so all these entries are 0. That means X is not reachable actually from any of these 3 nodes, but all other nodes are reachable. Okay, if you're starting from X, you can go to W, you can go to W like this also, you can go like this also. Okay, so this way you need to find out the path matrix, and you need to remember this formula. Okay, so algorithm is very simple. In that algorithm, what I have to do, I need to find out all these entries, I and J. I and J means, because this matrix is of size 4 by 4, 4 is the number of nodes. So first of all, you need to take a matrix of size 4 by 4, 4 rows and 4 columns. And this K is what? K is changing from 1 to 4, because you need to find out P1, 2, 3 and 4. This is already similar to A. So I need to make a loop, for loop, that is going through how many times that is being executed, 1, 2, 3 and 4 times the number of nodes. And then I and J, for each matrix I need to find out I, jth entry, here also, here also, here also, here also. And you know that if you want to find out each entry in this matrix, there would be 2 for loops. One is for I, another one is for J. Because when I is 0, you will be finding firstly this entry, then this, then this and this. That means when K is 1, I and J are changing from 1 to 4. Then when again K is 2, ij is changing from 1 to 4. When k is 3, ij is changing from 1 to 4. And when k is 4, ij is changing from 1 to 4. So this thing you need to remember while writing the algorithm. So algorithm is very simple. What you have been given? You have been given a graph G with m number of vertices. So what is m? M is the number of vertices, or you can say nodes. Okay. So here what I had told you, that first of all you need to find out P0. You have been given A adjacency matrix, you need to find out P0. This is like your P0. So if Aij is 0, you are saying Pij is also 0. Otherwise, if a Pij would be your 1. Okay. So this is how to find out actually your P0. P0 is similar to A. Now, what I have told you, that there would be 3 for loops. One would be for k. This k is to find out all the p's. Like it would find out p1 first when k is 1, then p2, then p3, p and 4. When k is 1, that means you are finding p1. But in p1 you need to find out each and every entry. So I and j are changing from 1 to m. First I 1 to m, j is 1 to m. You need to write down this formula, that Pij would be equal to Pij, this was the formula, or Pik and Pkj. You don't need to write down this subscript, because this is taking care of that. That when k is 1, it is finding each entry. Then after finding P1, k will become 2. Okay, when k is your 2, what's the meaning of that? You need to find out each and every entry in P2. Okay, so this would be your P2 entry. Then k is 3, you are finding P3. When k is 4, m will go till 4 only, you are finding P4. So all the entries in those matrices would be found, and in last you will be getting a matrix, a single matrix P. actually we need the last matrix only. So while doing manually, we are writing P0, P1, P2, P3 and P4, but actually it is a single matrix. Okay, when you are finding P1, that means this entry is being, every entry of this is being replaced by this. When you are finding P2, that means actually the same matrix is there, but each entry is being replaced by this one. When you are finding P3, each entry in this is being replaced by this. And P4 is that each entry in P3 is being replaced by this. So this is your answer. Okay, so this is your path matrix by using what? Warshall's algorithm. So you can use this one, Warshall's algorithm, to find out the path matrix instead of using the previous method. Okay. So again, I'm repeating here, you need to take one matrix that is called P0. Then by using this formula, or if your graph is very simple, you can do it directly. For all those entries for which there are zeros, you need to find out P1, P2, P3 and P4. So you will be getting the path matrix over here. So in my next lecture, I would be taking the Warshall's shortest path algorithm. So that is very important algorithm. So I would be taking it.